Is space expanding faster than light travels or slower?
Early on in the universe, right after the Big Bang, it expanded faster than the speed of light, but since then, no, it has not.
I would just think there would be, again, some overlap. If I'm looking, let's say, at the moon, and then two stars that are kind of in the same field of view, and one star is 5 light years away, one's like 1,000,000 light years away. Their light, again, so their light wouldn't change what I see from looking at the moon, let's say, in the moon's field of view.
Yeah, I mean, stars are on a scale. Those stars are stars in our own galaxy. Those are things that, yes, we can do that for. But if you're talking about galaxies are too far away in time and space for us to do something like that.
Okay. Is there any difference in viewing something that's so far away, it's so early that, again, it was expanding faster than light versus nearer field stuff that was expanding slower than the speed of light? Is there a discontinuity when you view out to a certain depth or a certain amount of years back in time? Are there jumps in what's observed or like discontinuities in what's observed?
Not that I'm aware of. Now, I did say that, the universe expanded faster than the speed of light right after the Big Bang, but that was for a fraction of a second. And so that's not something that we can observe in the way that you're thinking. And so that we would not see kind of a disjoint between that, which we cannot observe, and then what we can observe in the early universe. There is something that we can see change in galaxies, and we've seen this with GWST. We've observed some of these galaxies with Hubble, maybe 10 years ago, 5 years ago or something. We observed them with GWST, and we can see a supernova has gone off. And so you can kind of convert the amount of time it's been here versus the amount of time it would have to be there. And what we do see is that is a time scale, right? That we can see a change in the same source. And we found, I think within the first few days, there was a supernova that was found in the Sears images. And then there's been several more that have been found in the clusters that we've taken images of. You can see supernova, like big bright spots in specific galaxies that were not there the last time we observed them. And so that's been a pretty cool kind of thing to catch. These are much more distant. These are supernova in other galaxies, not in our own, not in nearby galaxies. These are very far away. And we just happen to kind of observe in a long enough kind of time frame between Hubble or JWST that we're able to see the supernova go off. And I'm sure if we observe them again in 10 years or so, that supernova will have turned off from our perspective.
Has the expansion rate of the universe continually slowed down, or was it faster and then it just settled to a certain constant rate and has maintained that rate?
Yeah, so that's an interesting question that a cosmologist would be better able to explain. But from our understanding, the universe is expanding and it was at a pretty constant rate. But recently in cosmic time, that expansion rate has sped up. It's accelerated. So the universe is now expanding at an accelerated rate than it was. And again, I don't think this would be noticeable on the time scale of like our observations like we've been talking about, but this is something that is still unknown. There's got to be some amount of energy being put into the universe on a whole scale in order to accelerate that expansion. And this is what we've called dark energy. And so trying to understand what is speeding up or accelerating the expansion of the universe is a big field of study. And a lot of cosmologists are looking into doing this. And we can observe galaxies at different times across large areas of the sky and try to measure how their distances change based on a couple different techniques. There's a really cool survey called the Eberly telescope dark energy experiment, or HETDEX, which is being done on the McDonald Observatory that is owned by UT out in West Texas. And so I encourage you to kind of look into that for some of the early results. That data is still kind of being taken, but trying to measure the distances to a lot of galaxies and see if we can see any kind of fluctuations in those distances, which is again not something I'm an expert in per se, but it is an ongoing field of study in astronomy that I encourage you to look into if you find that interesting.